Hello to everyone, welcome to the channel Educator, and this is Vishal, and here we learn sessions related to the courses of MCA, BCA, BTech and others. We have started some sessions on networking, operating system and Java and C programming, C++, oops, so many things be there, and varieties of subjects be here you can learn, and if you have any issues related to that you can ask to us or mail us. We started this theory of automata here. That's your first session and the basic steps we have to learn. So let us start. What is theory of automata? Okay, so here this is a syllabus in which we have to learn the Turing machines, models, computable languages, functions, many things. That means string processings, interactable problems, polynomials, times space problems. So that's your complete sessions in coming uh, 4 to 5 or 6 records. We can cover it with continue. So let us start it. The next slide. Okay, so if we discuss what is a computation in a simple language, so computations can be defined as finding a solutions to a problem from the given inputs by means of algorithm. So that means if you have an algorithm any, and that if you want to find something solutions, so that means we do some calculations using that algorithm and then give the output to that. So as our systems, computer systems doing nowadays. Okay, so that means if we give an example of simple maths, so what the maths doing, you have a problem, then you make an easy solutions for that and finding that the answer. So the same process we're doing that, but in a language of computations. Okay, so we have to start that simple computation process, how the algo works behind that, how the simple different theorems be working on that. So that's all we have to learn in theory of computation. So theory of computation is subfield of a computer science, and mathematics deals with finding a solutions to our problems. Or we can say that if we have a given inputs, we have to find some solutions for that and give the answers to our users. Okay, so as we know, for thousands of years computing was done with the pen and the paper, chalk slates, mentally sometimes. So that's with the simple processes we have done, but whenever computers enter, we have a lot of things we compute it, and it makes our life very easy. So theory of computations began in the early of 20th century. So that's you must learn for that. So simple computation. After that, we have to learn that how we can use that computation. So next step of computation be the model of computation. So model of computation means a formal abstract definitions of a computer. There are many models of computations which differ in computing power. So that means we have to work with that kind of model of computations and learn that. So simple serial models we have and the parallel models we have. So whenever you work with the serial models, we have to learn these things with the Turing machines, finite state machines, universal Turing machines, oracle Turing machines. There will be different names of computation processings as in a serial model. So that means in serially our data be entered. And the parallel models, the main three components we can say, or three models be here: the multiprocessors, work that model, and parallel random access machines. So you have to learn which is your simple serial model and which is your simple parallel model. So we have to learn first serial models be here. So let's start it. What is automata and Turing machine? The term automata is derived from the Greek word that means self-acting. So the machine which acted self. So that's your automata. And automata is an abstract self-propelled computing device which follow a predetermined sequences of operations automatically. So that means we have say that we have a automata, a automatic machine we have to design in which we have some algos be there behind that, and some calculations be behind that, in which we have to put some input and get some output. That's all be things automatically. So that is your computer. So we have to design these computers, and that was time in which we can use these kind of machines before making the our good approaches or a good machines on a computer which are using today. Okay, so that is the Turing machine. This is the model of computations, consists of finite state machine. Okay, so the next topic is finite state machine. So that means whenever you work with that automata, so here we can say that an automata is a self-operating machine. That is our finite state machine. An automata is a system which obtains, transforms, transmits and uses information to perform its function without manually interaction. So that means everything should be by the system. So the automata is a machine that has input tape that can be put into any several states. What are the states? How we can input? What be the process? That all we have to learn in this theory of computer science. What is the computation process? How we can make this kind of finite state machines? How we can solve our algos, and how we can build our some model relations. So these we have to learn in finite state machine, that is our automata system. So that means automation is a model of computation consisting of set of state, where we have a start state, where we have a end state, and in between we have a certain process. Okay, so that we have to work, and that we have to learn here. If we're talking about these machines systems, so that means you can see that certain notations we needed. So here we have a start, we have a final, that means final means double rings. Here we have a transitions, that is small arrow, big arrow input, and that open. So that be the same arrow. Okay, you can work with this. So the simple as M notation, finite state machine, we can say that here we have certain notation in which we have to work in, as enough practically that will show to you. So what components we needed for the finite automata? We need three important major components. Number one, your input tape. Number two, your read unit, and number three is your control unit. You always put it in the mind that we need three main components of any finite automata. Okay, so you can see that here we have a simple input tape in which we have some characters going on as in a string. So input tape, called the data type of automata, consists of a sequence of cells. So that means we need a multiple cells as in an input tape, and where we have an input, there will be some put the values be here like this. Okay, so this is your control of the system by the input. So that's first number one, that is a input tape. That's an important. So other two components be here, read unit. Read unit means the read unit of the automation reads words from the cells of the input tape and provides the individual words one at a time to control unit. So that means what we put as an input, it read it by the read unit. Very simple. And then it give it to the control. That means it passes to the control unit, and control unit doing the controller doing operations of the automations by performing a sequence of transition between the internal states and available to it. Okay, so that means every operation done by control unit, every input taken by your input unit, and everything be read by a read unit by the input system. So that's the way we can work in three areas. So here you can see this diagram be here. This is your input characters. This is your read unit. That's go to the process for the CPU. And at this time, I'm not talking about the CPU. I'm talking about the CU. That is called your control unit, because of this is a simple structure of FSM. Okay, so you have to make your own algos, and you have to create your calculations for that. So that's all you have to build. But what we needed for that, we needed some input, we needed some control unit, that means for the read values, and then this is a simple transformations or anything whatever we need it, and this is our temporary storage. So that's a simple FSM structure. If we're talking about the elements for the machine, so we needed the four main elements: states which define the behavior, and state transition which are movement from one state to other, and we need certain rules, and we have input events which are externally or internally generated. So these be the important four basic things or four basic elements we have to learn. That's very simple. So if we're talking about thus in a finite automata at any given time, the control unit is in some internal states, and the read unit of the automata read words from the cells of the input tape, and transition functions give the next state in the terms of current state, current input symbol, the information currently present in the temporary storage. That's very simple language we can say. If we say what how the FSM process, so here we need a simple input, then we have a read unit, then we have a control unit, and then state changes, and whenever the state changes, whatever be the state change, that's called your current state and current input symbol, and the informations be stored always in your temporary storage. So that's the way. So if you're talking about the state, so state is a complete set of properties transmitted by an object to an observer via one or more channels. Any change in the nature of quantity of such properties in the state is detected by the observer, and transmission of information occurs. Okay, so that means we have the state, and we have a start state, we have accepting states, we have a next states, we have a universal states, and we have a dead states. So there will be a lot of things for the states, but I am not talking about today because we learn it from practically. So we can say that we have a lot of things be as an a state. So we'll see next slide now. So today, in a very basic steps, what we have learned, what is the theory automata as a start, what is a simple Turing machine, what is FSM, which kind of diagram we need it, and that's all. So in my coming sessions, we done it practically one by one. We have to learn DFA, we have to learn NFA, Mille-More machine, and many more. So that's the tour. Coming sessions, we have to learn one by one, so we can complete this theory of computer science in a very easy steps. If you have any issue, you can ask to me. Okay, you can mail me or put it your comments below. Thank you so much for the day.